intelligence part in the Fabric. We all know analysis of the real-time stream is a very critical capability for any modern data analytics solution. So we can use actually this real-time intelligence capabilities which we have of our Microsoft Fabric. We can use it to ingest, to query, to process the streams of data. For all these purposes, we can actually use it. So far, whatever we have discussed, it was all more related to the batch data. If we talk about a modern data analytics solution, it will have two common patterns for the data analysis. What are those two common patterns? One is basically the batch data analytics. And the other one is going to be the real-time data analytics. If I talk about batch data analytics, it means that the data is loaded into an analytical data store at a periodic interval as a batch operation. So that will enable historical analysis of the data from the past events as well. And if I talk about a real-time data analytics, in this case, the data from the event is ingested in real time or near real time as the events occur in a stream of which can be analyzed, visualized, used to trigger automated responses. For all these purposes, we can use it. So batch data analytics is generally well understood. It is very commonly implemented also using the data warehouse or the Lakehouse architectures. But if I talk about the real-time analytics, it may be considered a more specialist kind of a thing. But increasingly, it is also being incorporated into the large-scale data analytics solution, we can say, in the form of a Lambda architecture, where we combine the periodic loading of the batch data for historical analysis with the ingestion of data streams for the real-time analytics. In Microsoft Fabric also, it has some capabilities for both batch and real-time analytics. So we are going to focus on the real-time intelligence features in Fabric in this particular lesson. We will be talking about the real-time intelligence scenario, we can say. So let's get started with the discussion about the real-time intelligence in Microsoft Fabric, how it is going to be within the Microsoft Fabric's environment. So if we talk about Fabric's real-time intelligence, it provides us with an end-to-end streaming solution. We get basically an end-to-end streaming solution, we can say. What it provides us with. And this is for real-time data analysis across the Fabric service. Real-time intelligence delivers very high performance of data for various sizes, for various ranges from, we can say, few gigabytes to several petabytes of data. It can handle data from different sources and it can handle the data which is coming in various formats as well. So Fabric's real-time intelligence workload can be used for solutions like the IoT, for the log analytics. In all these many scenarios, we can use it, including the manufacturing or the automotive. In all these scenarios, we can actually use this Fabric's real-time intelligence, we can say. So basically, in this Fabric's real-time intelligence part, these are the main components we can say of the Fabric real-time intelligence which we have within the Fabric. These are the main components of it. So let's get started. Let's discuss what are these main components talking about. So if we want to deliver instantaneous data insights and responsive automation through integrated services, it supports both streaming analytics and it also supports the operational triggers, we can say. So this is the very first one which we have, that is an event stream. What is an event stream? Event streams actually act as the entry point for the real-time data ingestion. It is kind of an entry point, we can say. We can create an event stream where we are actually capturing, we are transforming, and we are ingesting the real-time data from various streaming sources. So it's an entry point for the data, which is the event stream. It ensures high throughput stream processing with built-in schema transformations, we can say. That is basically what the event stream is going to do. Then we have Event House with us. What is this Event House? Event House is kind of a scalable storage engine for storing the real-time events. If you want to store some real-time events, for that we have kind of a scalable storage engine which is known as the Event House. It enables high-speed querying using the KQL, which is the custom query language. So in Event House, it basically helps you to query it will enable high-speed querying, we can say, using the KQL language, which is a custom query language. This Event House also serves as the foundation for exploratory and the historical analytics on the streaming data. This is basically what the Event House is going to do. Whatever captured real-time data is there, you can store those captured real-time data in the Event House, which also includes one or more KQL databases in it. Then the third component of this real-time intelligence is all about the KQL query set. So query set means that we can query and analyze the data in the Event House by using the KQL queries, which is organized in the KQL query set. Whatever queries are there in the Event House, that is organized in the KQL query set, we can say. So this is basically what the query set is going to support. It's kind of a querying tool, we can say. It's a tool for creating and running the queries in the KQL databases within an Event House. What is it? It's kind of a tool which is there within the Fabric, and it will help us to run some codes against the KQL databases. It is mostly used for the ad hoc investigations, the data explorations, for building some analytic logic over time windows. For all these purposes, we use the KQL query set. Then next we have is a real-time dashboard with us. What is this real-time dashboard? So basically, if you want to visualize the real-time data in real-time dashboard, you can do it, or you can achieve it by using the Power BI also. So which means that this real-time dashboard is going to provide you with a dynamic and an interactive visualization of your real-time data. You get interactive visualization and exploration of your real-time data. It also enables the stakeholders to monitor the key metrics and to monitor the trends as they evolve over time. It is integrated natively with the Power BI for the real-time visuals, we can say. That is what the real-time dashboard is going to support. Then the last component which we have as part of the real-time intelligence in Fabric is the Activator. Activator is basically, we can say, used to configure some alerts to trigger any automated actions. Like if you want to automate some actions which should be triggered by the real-time events, for those purposes, we actually use this Activator. It is going to configure the alerts, we can say, to trigger some automated actions. So this is kind of an automated response based on the streaming events conditions. Common use cases of an activator is basically alerting, the notifications, kicking off the downstream processes, these things. And if we have a look at this particular diagram also, we have got an ingestion layer. This is basically the event stream which is collecting all the data from the connected sources. This is the connected source. So all the data are coming from this connected source into the event stream. Event stream is collecting all those data. Then we have a processing layer, which means the data is flowing from into this event house, we can say. From this event stream, the data is flowing into this event house, and it can be queried by a KQL query set over here. The data which you have in the event house, you can query that data using the KQL query set. From this KQL query set, the data is surfaced in the real-time dashboard. After you query it in the KQL query set, you can move it further to the real-time dashboard. This option is there. Or you can move that data back to the Power BI also. Then we have also got an action layer, which is there. Action layer means the activator will listen for the patterns or the conditions, and it will take the actions based on it. That is what the activator is going to do. And also we have a storage integration, which means the real-time hub, which is there. This is a real-time hub. All the real-time data is unified and persisted in the OneLake through the real-time hub itself. This is all supported within the real-time intelligence part, we can say. Now we are going to talk about ingest and transform the real-time data, how we can ingest and how we can transform the real-time data. That is what we are going to discuss over here. So as we talked about event streams in Fabric, and as I said that it is basically used for capturing and transforming and loading the real-time data, which is coming from a wide range of streaming data sources. So whenever we set up an event stream in the system, we have to define a data processing engine, which will run perpetually to ingest and to transform the real-time data. And we tell it where to get the data from, where we should be sending the data, and how to change it along the way if needed. Those things we have to tell them. Now, talking about what are the data sources which is supported, what are the data sources for the event streams which is supported. The event streams which we have in Fabric, it supports a wide range of data sources, which includes external services. So when I say external services, it is just like the Azure storage, the event hubs, the IoT hubs, the change data capture feeds. All these are the external services. It also supports Fabric events such as changes to items in a Fabric workspace, or the data changes in OneLake data stores, or the events which is associated with the Fabric jobs, we can say. And third data source is the sample data. Sample data basically includes a range of samples that can help us to explore the real-time analytics scenario in the Fabric. So these are the data sources which is supported. Coming to the part, what are the transformations which are supported in the event streams? So we can actually transform the data as it flows in the event stream. It will enable us to filter the data, to summarize it, to reshape it before storing it. So some of the available transformations are filtration, which is available, filter. We can use filter transformations to filter the events based on the value of a field in the input. For that purpose, we can use it. Manage fields is another transformation which is supported. It will allow you to add, remove, change the data type, or rename the fields. For those purposes, we use it. Then we have aggregate, which is supported. We can use this transformation to calculate an aggregation. Like if you want to calculate the sum or the minimum or the maximum or the average, for those purposes, we can use it. Then we have the group by, which transformation is supported. So group by transformation is basically used to calculate the aggregations across all events within a certain time window. For those purposes, we use the group by. Then union is supported. We use the union transformation to connect two or more nodes and to add events with the shared files. For those purposes, we use the union. Then join is also supported. So join means we use this transformation to combine the data from two streams based on a matching condition between them. That is what a join is going to do. So all these are the data transformations which is supported in the event streams, we can say. Now moving on to the data destinations. What are the data destinations which is supported in the event streams? So we can actually load the data from our stream into all these destinations which is there. The very first destination is the event house. This destination will let you ingest your real-time event data into an event house, where you can use the custom query language to query and analyze the data. That is what the event house destination will support. Then we have Lakehouse as a destination. So this will give you the ability to transform your real-time events before ingesting them into your Lakehouse. We have Derived stream, which is another destination that is supported. So this destination is actually used to redirect the output of your event stream to another event stream. For those purposes, we use the Derived stream. Then Fabric Activator is another destination which is supported. So Fabric Activator's destination will let you directly connect your real-time event data to a Fabric Activator, which is an intelligent agent, we can say, that can automate the actions based on the values in the streams. That is what the Fabric Activator is going to do. Then last destination which is supported is the custom endpoint. So if I choose this destination, which is the custom endpoint destination, we can route our real-time events to a custom endpoint. So this destination we can say is useful when you want to direct your real-time data to an external system, or if you want to direct your real-time data to some custom applications which is outside Microsoft Fabric, for those purposes, we can actually use this particular custom endpoint, or we can say the destination. So these are actually the supported sources, transformations, and the destinations which we have. Now, how we can store and query the real-time data? So event houses are where we store the real-time data. We already discussed that event house is where you can actually store all your real-time data, often which is ingested by an event stream and then loaded into the tables for the further processing and the analysis part. So within an event house, what you can create? It's a scalable storage for querying and querying for real-time data. And within this event house, you can actually create a KQL database also, and you can create a KQL query sets also. What are both the things? Let me tell you. So KQL databases means that it's a real-time optimized data store, which can actually host a collection of tables or a stored functions or some materialized views or some shortcuts. These things it can basically host a collection of. That is what a KQL database is. Data stores which is built on the Custo database engine. It is optimized for the time-based data. We can query them using the KQL language, which is the Custo query language, with the queries which is managed in the KQL query set. So whatever queries are there, it will be managed within the KQL query set. KQL query set means it's a collection of KQL queries. KQL query sets has got a collection of KQL queries that we can use to work with the data in the KQL database. So basically, it's a query set which will support the queries that is written using the KQL language, and also it supports a subset of the Transact SQL queries. So SQL queries, subset of Transact SQL language is also supported, we can say. It's a built-in tool and templates for common query tasks. Copilot for AI assistance also it has. So this is basically how we can query in the KQL query sets. What all things are basically included in the KQL query sets. Now, Copilot for AI assistance says that basically within the Fabric's environment, it includes the Copilot for all the real-time intelligence as well. So this will help us to write the queries that we need to extract some insights from our event house data. Copilots basically uses the AI to understand the information which we are looking for, and also we can generate the required query code for us. So that is what the Copilot for AI assistance is going to help us with. Then comes the part where we can visualize the real-time data. So we have the option of real-time dashboards, which is there. This is the real-time dashboards which we have. It will provide us a way in which we can pin the data visualization to a single visual interface. It will also enable us to surface the real-time insights at a glance. So basically, we would be having tile like this. This is one tile. So each tile in a dashboard will show us different information based on a KQL query that extracts the real-time data from the tables in an event house. So this real-time dashboard is basically a component on the Fabric real-time intelligence itself. It's an interactive data visualization tile which is based on the KQL queries, we can say. So if you want to create some real-time dashboards, you can do it. You can create this real-time dashboard in a workspace, and then you can actually configure its source, or you can create one directly from a KQL query set in an event house. All those things you can do. You can also visualize your real-time data with the help of Power BI. If you want to visualize it in Power BI, that is also supported. Why? Because we all know that Power BI is a core component of the Fabric's platform. So we can also visualize the data in the KQL database as a Power Query report. This is how it will look like. It's a core component of the Fabric platform. We can create the Power BI reports from a KQL database. So this is basically how we can work or visualize the real-time